The other science packages aboard Parker include SWEEP and ISIS, designed to study the particles emitted in the solar wind.
ISIS, the Integrated Science Investigation of the Sun, is an experiment which looks at energetic particles over a broad range of energies, from tens of thousands of electron volts up to about 100 million electron volts. The ISIS instrument is based on solid-state detectors. Those are detectors that when a particle passes through them, energy is deposited, and you can measure that energy, and you can measure that the particle has actually passed through. So there's the solar wind, which is this continuous flow of lower energy particles. And then there are much more sporadic and episodic events like solar flares that spew out great numbers of these much more energetic particles. In our higher energy instrument, we have a whole set of layers of these detectors. And when a particle passes through those layers, it leaves energy in each and every one of those detectors. Those detectors are also segmented in pieces like a pie. And so when a particle comes through from a particular direction, you can tell both the direction the particle came through at, and you can tell the energy and species of that particle.
The SWEEP investigation consists of 3 separate instruments and a central electronics box. Most of the instruments within SWEEP sit on either side of the spacecraft, stare out over the entire sky, and make maps of all the different particles and what energies they're moving at, what types of particles they are. The purpose of SWEEP is to measure the bulk of the solar wind and the solar atmosphere. One of the biggest questions we want to resolve with Solar Probe is how the corona and the solar wind are heated. In order to do that, we need to see if there are waves that are coming from the sun and depositing energy within the solar atmosphere and the solar wind. So we have a series of sensors across the spacecraft that will collect individual particles, electrons, fully ionized hydrogen and helium, which we call protons and alphas, and other minor ions, and make maps of the number of particles as a function of their speed and energy and type. We take those maps on the ground and we can interpret them to figure out the temperature, the density, the pressure of the solar wind and the solar atmosphere.
Learning the secrets of our star, the Sun, will help us understand the nature of the solar system and its all-embracing influence on our world. But the Parker Solar Probe is not the only mission destined for that star. The European Space Agency is also in the game. In collaboration with NASA, the Solar Orbiter is set to launch very soon and will be joining Parker in its quest for knowledge. The orbiter will fly in elliptical orbit within the orbit of Venus, but on a much greater inclination off the ecliptic, giving it access to the poles of the Sun. Unlike the Parker probe, the orbiter's main observation instruments will appear through the solar shield at a safe distance, then reconfigure when making a closer approach. Together, they will reveal the secrets of our closest star, the Sun.